All right, we're going to look at y equals arc tangent of x. And so if we remember our arctangent function, it has a limited range due to, if we think about our tangent function, so if here's tangent of x, it has a period between negative pi and pi over 2, and it takes in values and it's asymptotic towards infinity. So the domain of our tangent function is negative pi over 2 to pi over 2, and its range is negative infinity to positive infinity that it puts back into these. Now, that being said, the arctangent then flips this, and it can take in any real number, but its output's going to be limited between negative pi and pi over 2. We're going to use the relationship if we'll say that f negative 1 of x will equal arc tangent of x, or the inverse function, and that means the function that we're taking the inverse of is tangent of x. So that means we need to get the derivative of tangent of x, which is secant squared x. And some things we know about secant squared x, again, we have a squaring going on here, so we're going to have a Pythagorean relationship. So again, our Pythagorean relationship comes from this. The squares of cosine plus the squares of sine will always equal 1. Well, I can divide everything by cosine squared. And that's tangent squared. And that's secant squared. And I warned you when we looked at these earlier that you will see these two things linked together a lot, which is why secant and tangent, we'll see these things linked together. So if I want to find my derivative of the arctangent, so we're going to find the derivative of this, then we'll use our inverse rule, which this is the derivative of the regular function evaluated at the inverse function. And so in our case, it's going to be 1 over secant squared x evaluated at arctan of x. And we're now going to use this relationship to get 1 over 1 plus tangent squared of x, tangent squared of arctangent of x. And so notice the game we've been playing here is we've been getting the original function and the arc function to appear together so they cancel each other out. Because if we, again, expand this out, this is the tangent of arctangent x, everything squared, and an inverse and its regular function will leave us just with x in here. So this is x squared. And so we get 1 plus x squared on the denominator here. And so we can now add the derivative of arc tangent u, and we'll do x and then we'll do u differently, the chain rule still applies, is 1 over 1 plus x squared. And if we are looking at the derivative with respect to x of some function that is a function of x, then we get 1 plus 1 over u squared du dx, because the chain rule falls into play. And so we've now added arctangent to our derivatives.